All right. Yeah, sorry about that. We had a bunch of TV stations over at the makerspace about the masks, and they knew I had class at 10, but the person that was supposed to come over and take over the interview stuff did not show up to take over the interview stuff. They're pretty reliable, so I'm sure something legitimate came up, but
Was the person Clancy?
it was not Clancy. I would not rely on Clancy to do interviews.
That's harsh,
It's Clancy. But you want evidence, I guess, watch the local news. I'm guessing tonight or tomorrow. All the different stations were there, so I'm sure we'll have something going. Okay.
What exactly were you what exactly were you doing? Like, if I submit,
Like, what are we doing at the makerspace?
yeah.
We are creating, we're 3D printing COVID-19 masks.
Oh, that's what you were talking. Okay, yeah, I remember you talking about that a couple weeks ago.
Yeah, so they were coming and doing a story on that whole thing.
All right, cool. That's pretty
And,
cool.
Sarah and Brocker are both helping as well. Well, I say helping; they're doing more than I am. I'm just the I don't know, email person. They're both doing stuff, actual stuff. We got a whole bunch of new printers, so when all is said and done, we'll have 100 total printers in there. Oh, and Brocker, the laser cutter, is down by the makerspace now, so we have to learn how to use that to cut things with lasers.
Awesome.
All right, so let's see. Was there homework for today? Oh, no, I just had you redo the homework from that was due on Tuesday in the context of what we talked about last class, right? About picking the correct data structures and that kind of stuff. Okay, so last time we had talked about how we were going to implement our rooms, doors, and students, and we had decided that our collection of doors for a room would be done as an array. Because we had a somewhat limited number of rooms that we were going to have to deal with. I think we had kind of said that there wouldn't be any more than 10 rooms or 10 directions, 10 exits. But the number of people that might be in the room could be much larger. Now, this is kind of being a little forward thinking, because right now it's kind of a single player game, if you will, where we have this student who is moving through in my map, the computer science department. But if you think about the normal cadence of things, you might have many students all interacting autonomously in the department, or being controlled by the end user. So if we have time to get to it, we'll actually create a multi-user type setup. But at the very least, initially, we'll have inhabitants and things like that in there, where we can have things we can fight and pick up and whatever, that kind of stuff. Okay, so let me go over here. I don't know, what do we call this guy? Dungeons and data structures. All right, and then I want to talk about a couple of things here. If you noticed from the code I gave you, and I did put a comment in one of them. Let's see if I can find the one I had the comment in. Was it room? Yeah. So notice here that instead of including door.h and student.h, I actually have this directive called class door in here. So the issue here is that a room has a collection of doors, for example, and a door is associated with a couple of rooms. So door relies on room, room relies on doors. Now the way that include statements work, when I say include room HPP, at compile time, this line right here will turn into all of this, this HPP file. So we could just write it all inside of a single file if we wanted to. But instead, the include lets us have things in multiple files, and then it kind of brings them all together into a single file that's being that's going to be linked. With that in mind, where's my door? If door relies on room and room relies on door, and they both would have include room HPP in them, what we'd end up having is this circular infinite loop where room and door would keep including each other in them in perpetuity, and that doesn't work. So to get around that problem, what we can do is we can give the class directive here, which says, this will tell the compiler, this is kind of like a prototype, that there exists a class called room, trust me, which allows us to have this type of thing. When we actually get to the implementation code after the headers, that's when it'll start picking up what is capable of being done in room and that kind of stuff. All right, so that's why in some of our classes, like in student, I think, let's see now, student uses, that is student node. Yeah, so here in student node, we're able to include student HPP because student node relies on student, but student does not rely on student node. So we were able to use our traditional include statement instead of the class directive. All right, so does that make sense why we need to have that class directive to support classes that rely on each other?
You said that if you put just the include statement, it would create an infinite loop. So why does that exactly? You said it would create a circular thing, but I'm kind of confused with how that exactly works. Is it because we put it in multiple?
Yeah, it's because of this. When I say include room HPP here,
Yeah.
at compile time, this one line will turn into the entire contents of this file.
Okay.
This file, if I had include door, so remember I was in door here. Okay,
Right.
so if I had include door, and actually, I don't even need this include statement here because I've actually brought in the class here. So this include statement was actually not needed, and it actually would have broken it if inside of room I also included door. I didn't. So if I had included door.hpp in here, that would bring in everything that's inside of door.
Right.
And if I had included room HPP inside of here, that would have brought in everything that's in room. Which
So okay. I see. It creates an
room,
infinite loop.
which includes door, which includes room. So
yeah, so it goes back and forth basically. Yeah.
Yep. So
Not
to
what
not
needs done.
have that, we had to not use the typical include statement because of the way includes work. Includes work by just replacing this with the contents of that file. And instead using the class prototype. This is just saying there exists a class called room. Trust me. That way, when it's doing the tokenizing and the compiling of this file and it gets to this, it says, okay, room pointers are allowed because you have a class called room. I don't know anything about it. I'll trust that at some point you're going to have implemented it and I'll get the details, but this allows this guy to compile.
Okay.
That makes some sense?
Yeah.
All right. And then I think which file was it in? Our link lists. Was it right here where you said there was a bug? Should be -2.
Yes.
Yeah, so we're positioning the cur node to the guy before the last guy. So less than this dot count will be the last guy. This dot count -1. Are you sure? Wouldn't this get me to the guy before the last guy?
Yes, and then you're calling get next node again on 68.
Oh, yeah.
You're calling
So this is fine as long as I say cur node here.
Yes.
I have to change one of the two. Yeah, so I probably like this version of it better because this for loop does what it says it should do. It positions cur node at the node before the last guy. Well, no, hold on. The guy I'm returning here though is I'm removing at index. So if it's a So if the index is 0, do this. If it's the last index, then we're doing this stuff. So this says position me at the guy right before the last guy. Then the guy I'm going to return would be the last guy. So this should be cur node get next node. That should be the last guy. Get payload. That's the guy I'm going to return. So the node to delete would be cur node get next node. And then we'll disconnect cur node, and then we'll delete the node to delete. This looks correct to me.
So with count -1, that positions you. So count -1 is the same as the last.
Oh, that's the last legal node.
Yeah.
That's the last legal node for the same reason that we asked this question right here. If index is equal to count -1, that's it. Yeah, so count -2 is the actual guy before the last guy because index count -1 is our last index. We have count number of nodes in the linked list with the but it's 0 index just like an array. So it's bucket 0 to bucket count -1. Count -2 would be the guy right before him. All right, I get it. So I either have to fix it here or I have to fix it in all these places down here. But this is more correct here because I do want to position cur node at the index previous to the last node. Okay, otherwise we're removing from the middle, so we'll go ahead and write that. So if we're not the first node and we're not the last node, we'll go ahead and remove somewhere in the middle. So if we're removing somewhere in the middle, we need to zip up to the guy right before the guy we're removing. So if we're in this else, we know that we're not at the beginning, we're not at the end. So there's the guy we're removing definitely has somebody after it, and he definitely has somebody before it. So I want to go up to the index I'm removing -1. So we'll say student node pointer cur node is equal to this head. And we'll go up to, so we'll say for int I is equal to 0, I is less than index -1. This will be the guy right before the index we want to remove. I plus plus. We'll say cur node is equal to cur node get next node. So we'll zip down our list, positioning ourselves at bucket index -1. So that's where cur node will be. So now we need to set cur nodes. Well, we're going to go ahead and get the student to return. So the same thing we did before, student to return is equal to cur node. Actually, it's this exact same thing here. So the guy we're actually going to disconnect is the next guy after cur node. So cur node, get next node. Then the node to delete is going to be this guy. Let's actually, well, we're going to need to do this. This is going to be the node that we're actually going to delete. All right, but now before I can set his next node to nothing, I need to set cur node's next node equal to node to delete its next node. Cur node set next node to node to delete get next node. So now cur node's next node is the same thing as node to delete's next node. So cur node no longer points to node to delete, but I preserve that. Now we can say node to delete, set next node to 0, that fully disconnects it. Then we can delete node to delete. And in the end, we will return the student to return, which we set regardless. So this is the index that we're going to return. We set it here. We set it here. So any way you cut it, we're going to return that guy. But what we do in between will differ. So in this else, that means I'm removing somewhere in the middle. So I'll zip up to the guy right before the guy I want to return. Then I'll get the guy I'm going to return. I'll get the node that I'm going to delete. I'll update cur node to point to the guy after the node I'm going to delete. Disconnect the node I'm going to delete, and then actually delete the node I'm going to delete. All right, that look okay? So that should be our linked list of students. And we'll go ahead and test that real quick. So my student constructor takes in some names. I actually don't have constructor, or I don't have getters for these. So let me go ahead and get the name and get current room. So we will add a couple more abilities to students. So we're going to have a string get name, and we'll have room pointer get current room. I'll take both of those and we'll go and implement them inside of student CPP. And this guy will return this name, and this guy will return this current room. All right, so now students can report to us their name and things like that. So what we want to do here, just to test our linked list of students, is we're going to go ahead and let me just quickly look at what this guy can do. I can add a student to the front. Okay, that'll work. So I'm going to go through and so I have a get count. I'm going to add a get count to my linked list. Oh, I haven't written index up yet either. So get count will return this count. Index of is going to search through our linked list and return the index where we find that student, or -1 if we don't find it. So for int I is equal to 0, I is less than this count, I plus plus. And then we can go ahead and we can use our get at index. So we'll say if this get at index I is equal to S, if this memory address is the same as this memory address, these are pointers, that means I'm looking at that specific student, I'll return I. Otherwise, I'll return -1. Now, you could have also written this, because this is a little bit inefficient in that I'm using get at index to traverse my entire linked list each time, rather than just starting off at a, so if I wanted to write this a different way, I could have said, what is it, student node, pointer cur node is equal to this dot head, while cur node get next node is a thing. If cur node get payload is equal to S, I need to return a position. So I'll start pause off at 0, return pause. Else pause is always going to increase. In the end, return -1. And then we need to set cur node equal to his own next node. All right, so this code here does the same thing as this code here, but actually in this case more efficiently because I'm manually traversing the list in here. Whereas down here, I'm relying on get at index to get me the node that lives at a particular bucket. And the issue with that is that guy each time traverses the list. So it's going to run to bucket 3. Next time through, it'll run to bucket 4 from bucket 0. The next time through, it'll run to bucket 5 from bucket 0. So we're doing a lot of extra traversing of the list using this. Not the end of the world. In fact, if you look at this code from a reading perspective, you know, I think this probably looks cleaner. But, you know, pick your poison. We'll write it like that. So we'll spin through the list and we'll return the index of S in that list, or -1 if it's not found. All right. So now I have what should be a complete linked list. I should have a student that I can fill up my linked list with. So we're going to go into driver here. And we're going to include linked list of students. And I'll include student. So let's say for int I is equal to 0, I is less than 10, I plus plus. And before this, I need to actually create my linked list. So I'll create a linked list of students pointer LL is equal to a new linked list of students. So it'll give me an empty linked list. And I'll say LL add front. I'm going to add a new student. And we have to give this guy a name. So why don't we say name concatenated with I. Now I think this is going to treat this as a char pointer string instead of a string. So that work? It should work. This, that closes this. Oh, I have an extra guy here. Doesn't like concatenation. No matches. The string type supports concatenation, doesn't it?
I thought it was like really weird, like the format for it.
Unless it wants this entire thing to be treated as a so that string concatenated with my I, and then convert it to here. I want to test something here real quick, if you will indulge me. Let's just make sure it's giving me the values I think it should be giving me. Okay, it is not. So it should be string version of name. So start with that. So it should just be name a bunch of times. Okay. And then I should be able to concatenate onto that the value I. But it's saying it doesn't work for ints. So do I need to convert that int to a string? What is it? ToString I. So it's like Python where concatenation, yep. That's it. So the string class, you have to have a string on both sides in order to concatenate, it appears. So LL add front. I'm going to add front a new student. ToString of I, so that ends the new student. So this is an extra one. Okay. That ends that for new student. That ends. All right, so I'll add to the front that guy. Let's just run this and make sure adding to the front doesn't break anything. All right, seemingly we can add to the front. Let's now do a cout LL get count. Okay, we got 10 things in there. And then we'll just spot check it. We'll say get it index 4. And that guy is a student. So if I were to just print this out, I should have a pointer to a student. So there's my pointer. And now I want to get that particular student's name, which should be like name, bucket 4 should be what, name 3? Zero, 1, 2. Oh no, it's name 5. Bucket 4 is the 5th name. I don't know why I subtracted 1. Where were you on that one, Clancy?
Not bad.
Yeah. All right. So that seems to, here we can just spin through the whole thing. Oh, actually, let me. We'll say for int I is equal to 0, I is less than LL get count, I plus plus. We'll put this guy in here and we'll say print out bucket I. This should show us all of our things. All right, remember we were adding to the front. So it's, so actually, I was wrong the first time for the wrong reason. Because actually I forgot we were adding to the front. So bucket 4 is a 5, but only because it happens to be a thing of 10. If it wasn't 10, if it was something where that guy was not in the middle, then we would have had a problem. 1, 2, 3, 4, yeah. All right, so let's go ahead and let's remove something from the beginning. LL, remove at index 0. We won't do anything with it, but this should get rid of the name 9. All right, so we have a, so the 9 is gone. Oh, we didn't decrement count inside of our linked list remove it index. Yeah, any way you cut it, we are removing something here. Okay, so we removed from the front. Now we'll remove from the end. So LL, remove at index, the new end will be bucket 8, right? Yep. And then let's remove bucket, what, 0, 1, 2, 3, bucket 3. That'll get rid of the name 5. Okay. So I feel like we've exhaustively tested our linked list. It has 0 bugs in it now. All right, so get an index, remove an index. We did remove. We didn't try index of. Let's just test it real quick. That should be pretty easy. So let's ask for something. Actually, I don't have my my student pointer. I need to hold on to my student pointer. So let me. Well, we have an added index. We don't. So I need to just remember one of my students. So inside of driver, I'll go ahead and say student pointer S is equal to null. We'll say S is equal to all this stuff. And then we'll add S to the front. So the last time through, S should be the very last thing that we added. I won't remove anything yet because we were removing the last thing. So I'll go ahead and do a cout LL index of S, and it should give us a 9. Oh, actually a 0 because we added to the front. So now let me remove the front. LL remove at index 0. Now it should give me a -1 because I removed the guy before I searched for it, so he's no longer in that collection. There's my -1. Okay, so let's say our linked list works now. So now getting back to our construct for this guy inside of our, here let me actually just push this real quick. So if any of you want to look at this version of the code, you can. Okay, but we're going to make revisions to main now. So you'll have to go back and look at a prior version of main to see how we tested our linked list here. All right, so we are going to have a collection of rooms. So we want to build a map that looks something like this. So we need to build all these rooms. And then we need to build the connections between them. And so we need to build these doors. And I think we decided that our door would be a two-way door. So it would have rooms and then directions between them. So we need to build these rooms first. So let's go ahead and just start building the rooms. For time here, I'm going to just keep it to just a couple of rooms. So we're going to build this little quadrant in here. So we'll do lobby, esports server room, and Locklear's office. So I'm going to need to include room. I won't need our linked list anymore in here. All right, so I'm going to create a room pointer, and we'll call this guy we give these guys room IDs in our picture. We did not. Are we storing room IDs in here? We are not yet. Okay, that's fine. So I'm going to create lobby, esports server room, Locklear's office. So room pointer lobby is equal to new room lobby, and I think, is that what room takes in their constructor? Just takes the title. Okay. Room pointer server room is equal to new room. Server room. Room pointer esports is equal to new room. Esports. Room pointer Locklear office is equal to new room. Office. Okay, so those are our rooms. Now we need to create our doors. So in our world here, we have a door going from the lobby to the server room. So this guy. We have a door going from the lobby to esports. We have a door going from the lobby to Locklear's office. Let's create this first door here. So we have one leading to the north to server room, and then leading from the south back to lobby. So we have door pointer. Now for rooms, do we already write it into room? We have not yet. So we're gonna have to leave it like this for right now. So we'll call this guy D1 is equal to a new door. And our door constructor takes in the direction to room 1 or to room A, and then we'll go to room A. So we'll say north. So we can decide who's going to be room A and who's going to be room B, but we'll say north to room A and then south to room B. So north to the server room, south to the lobby. That's the connection that that particular door makes. Oh, I need to include. So actually we're back to that same situation we had before. If I do an include door.hpp like this, why? Oh, it's okay in here because we are not inside of door or inside of room. So we don't have the circular problem. We are getting room and door HPPs in here, but because we're not in one of these guys themselves, we don't have the circular infinite loop. So we have our room, we have our door, because right now it's governed by our if not defined thing. So I think technically we can actually get away with it without the door. So this guy actually is not getting processed because this guy processes it for me. But we need it here for the initial compile, because when it goes through and it tokenizes, it doesn't know what this guy is unless it has this. So we could do the class directive for door and accomplish the same thing. Just letting this guy know that a door exists. All right, so I created that first door. That's this one here. I'll create this door. So this is going to be west to Locklear's office, east to lobby. Door pointer D2 is equal to new door, west to Locklear's office, east to lobby. Door pointer D3 is equal to a new door. This is going to be south to esports, north to lobby. All right, so that represents our little part of the map here. So this little world right in here. Okay. Then we can go ahead and we can create our player or student. Student constructor takes in just the name. We'll do include student HPP. We'll say student pointer. The student is equal to a new student, Mr. Gonzalez. Actually, it's Reverend Dr. Gonzalez now. All right, so, and then we would end up adding him to one of the rooms. Well, actually, we would set so we could say something like the student. I don't think we wrote setters and getters in that guy yet, so we will next time. Yeah, so we need to be able to set the current room so we can tell him he's in the lobby. So we'll end up putting him in the lobby right off the bat. All right, so we're pretty much done. Once we put him in the lobby, then we'll just give ourselves a loop where he'll go through and can walk between room to room to room to room. We do need to let each room know about the list of exits that the list of doors that is associated with that room. We've created the doors, so now we need to say lobby, add door, D1, D2, D3. We need to say server room, add door, D1. Lockler's office, add room or add door, D2. Esports, add door, D3. Because when a current player is in one of those rooms, he needs to be able to see the list of exits that we're going to support as an array. All right, questions, comments, concerns, bribes. All right, so no homework over the weekend. If you didn't quite get this done, if you ran into some bugs, you can turn it in by, you could have the weekend to work on it a little bit more if you were still struggling with it. Just give me a note when you submit it because it'll show up as being late. But I want to take a little bit of the stress away for over the weekends because that might be your time to catch up on things at home with everything that's going on. So no homework for Tuesday, but we'll pick up where we left off here on Tuesday and get this thing going and then upgrade it. Sound good?
Yep.
All right. And again, sorry I was late. It was out of my control, but still not a great excuse.
Are we going to be working on this project for like the remainder of the semester?
Yeah, I think we're going to work on the project for the remainder of the semester, but we're going to keep adding abilities. So if I was giving you a little foreshadowing, we're going to upgrade the way that we're reading, that we're getting stuff in here, then upgrade the way we're building our map, because we should look at this and say, where's in driver? We should look at driver and say, yeah, this is going to suck for a big map. So we want to have some other way of representing our map and reading it in. Maybe we do that through like something like JSON or something like that. Then we're going to add a little fight component to it where we'll have like a rat or something like that we can fight. And then if we have time, and I'm not necessarily thinking we will, I want to do a little network stuff where we can maybe have the game client running on different computers and then having multiple people being able to join the same shared world. That's more of a systems programming thing. Is that in the next spring? Or is that next 470s in the fall, 450s in the spring? So we would probably get to network sockets and things like that in the 450 class. So I don't think we're going to quite get to that, but if we do, that'll be a fun thing to toss in.
Okay, I kind of want to make like a visual interface for it to like actually display the map and like put like an X in the box that the user is.
Yeah.
Could you help me with that over Zoom over the next couple weeks?
Sure. We'll have to set up some times that are relatively convenient, but yeah, we can make that fly.
Sweet. Thank you.
All right. Other questions, comments, concerns?
Can I get into that Zoom meeting as well?
Nope.
Figured.
Yeah, you guys figure out what schedule works for you, and then let me know, and I'll show up if I can. Otherwise, if you're going to build a visual interface and you want to use C++, I'd probably encourage you to look at Visual Studio. Otherwise, if we're doing it here in Linux, not that the windowing interface in Linux isn't easy, but you have to do it in terms of like GNOME or KDE, one of the known windowing environments. I think life will be easier in Visual C++, and that'll be a skill that's more applicable to real life, because you might do graphical programming in Visual Studio in your job. In fact, I think Colin is doing that as part of his internship. So that would be a valuable skill. I guess maybe I might wait till the summer because you're going to have a lot of stuff kind of popping up over the next couple of weeks. But choose your poison. But that's the punchline. All right, I'll see everybody on Tuesday.
Thank you, Professor.
Yep, you take care.
You too.
Just never forget rule number 1 for the weekend. I watched that movie with like no idea what it was going to be about. All I knew is that it featured Zach, and I kind of heard Shia LaBeouf talk about it. But yeah, that was a great movie. Very happy.
Oh, it's so good.
That was almost like, it was weird because I feel like Shia LaBeouf in the past couple of years has kind of set him up to be like,
kind of gone crazy.
Yeah, and gone crazy. But I think he kind of cleaned up, and I recommend you watch the movie Honey Boy because it kind of is like a self-based story about how he had like an abusive father growing up, and
What's it called?
It's called Honey Boy. I think it's free on Amazon Prime Video. So
okay,
I recommend it. It's pretty good. I don't think it's as good as as Peanut Butter Falcon, but it kind of gives some insight as to what his life was like. And yeah, also check out the Hot Ones interviews on YouTube with Shia LaBeouf. That one was really good. He kind of talked about that a lot, and really good. So yeah, really a good film in terms of like feel good and kind of taking a look on, stuff like that. I don't know.
Yeah.
All films like that are usually pretty well received, I think. And
Sure. But I mean, there's just some great one-liners. It's like you got any money? I don't have any money, and I don't have any pockets.
Yeah. I just thought that whole Zach was just great movie overall. Just because I don't know. I think from the second he slathered himself up in soap and slipped out the window, but he didn't grab his clothes and just kept running. That was too funny.
Yeah.
Funny.
Yeah. What's rule number 1? Party.
And then 5 minutes later, he's just like, "Yeah, it's party. We're gonna accept that." All right.
All right. Yeah. Catch you later.